make sure you grab a piece of paper, a pencil, and a calculator. Today's discussion will center around this topic, stoichiometry. At this point in time, I'm sure that you have many tasks that you've been able to do in chemistry and in the realm of stoichiometry. For instance, you could probably take elements and put them together to make compounds, maybe calculate molar mass and do dimensional analysis. I'm sure that you can create chemical equations, and the tasks go on. But sometimes students get confused. I know I was confused when I was a student, looking at problems and trying to apply all of these, related tasks that we were able to do. So what I'd like to do is offer you a framework of ideas from the kitchen to understand how to actually do a stoichiometry problem. So the first thing that I'd like you to consider is recipes in terms of chemical equations. So if we took a standard recipe of, say, popcorn balls, what I'd like to challenge you to do is create a chemical equation from this information. Notice you have your ingredients and you have the outcome or the product that you're actually trying to produce. You can pause the video to create that chemistry equation. If you noticed, this particular recipe is strategic in having the same units throughout. If you created your chemistry equation like this, all of your ingredients yielding your product, then you are on the right track. When we consider our chemical equation, we recognize that each of the numbers that's associated with that chemical equation is actually in moles. The next thing that I'd like you to consider in that framework is the thought of conversions. So conversion factors or conversion tables, I use this handy dandy tool that tells me 1 cup is equal to 8 ounces, it's equal to 16 tablespoons, etc. I use this to convert between some of my units. Just like we use the periodic table to convert between the various elements in the periodic table. So if you notice down here, these values represent the mass. So 1 mole of chlorine is equal to 35.4 grams of chlorine. Remember that 1 mole is equal to 6.02 times 10 to the 23 units of whatever that might be, in this case chlorine. So 1 mole is equal to 35.5 grams of chlorine, which is equal to 6.06 times 10 to the 23rd units of, in this case, chlorine. We could also talk about it in terms of carbon and sulfur. Each of those molar mass units are different. So 1 mole of carbon, 6.02 times 10 to the 23rd units of carbon, is actually equal to 12.0 grams of carbon. Same thing applies to sulfur, etc. So think of the periodic table as being that, that conversion factor when you think about each of the elements and in terms of moles. So we're converting between moles and mass. The last framework that I'd like you to consider is if you open up the refrigerator, you actually get to see what you're given, what you have in the refrigerator, what is yours in order to make a particular product. In this case, I have 4 tablespoons of butter. So the question is, I have 4 tablespoons of butter. Can I make my recipe? Well, certainly I can. But keep in mind when I'm using my conversion table of 4 tablespoons of butter is actually equal to 1/4 cup of butter, my recipe is calling for 1/2 cup of butter. So I have to utilize dimensional analysis, and I say 4 tablespoons of butter. I know that 4 tablespoons is equal to 1/4 cup. Therefore, I have 1/4 cup of butter. Okay. When I do my dimensional analysis, I'm converting between the units of tablespoons to cups. All right. And then I'm taking that relationship and I'm saying, okay, well, if I have 1/4 cup of butter, how much popcorn would I need in order to make popcorn balls? So I take 1/4 cup of butter, and I look at that relationship of 1/2 cup of butter to 16 cups of popcorn. And I see that I only can produce, or only can use 8 cups of popcorn. The relationship is the same between the butter and the popcorn balls, so I would be making 8 popcorn balls. So let's take that framework and look at it in terms of how we might relate it to a problem, a homework problem that we might see. So take a look at this. Grab your paper, your pencil, and do your best to actually calculate the values that they're asking for. You can pause the video in order to do that. Alright, so I'd like to quickly go through that framework that we were talking about. This problem is asking us how many grams of carbon disulfide is required to produce 5 grams of carbon tetrachloride. Right? So, and I see that I don't have that. It's 5 grams of carbon tetrachloride. So it's asking us, if we were to open up the refrigerator, how many grams of our ingredient would we have? Is that what it's asking? How many grams of, here's our ingredient, it's actually questioning, if we opened up the refrigerator, how much would we have to have in order to produce 5.00 grams of carbon tetrachloride. So in this case, we have to use our imagination a little bit. It's not always going to be straightforward. Let's open up the refrigerator, see how much we have in our refrigerator. It's saying, you know what, if you were to produce this much carbon tetrachloride, what would you need in the refrigerator in order to make that amount? Just like we would ask if we were throwing a party and we wanted to have a large number of popcorn balls at our party, we would be asking, if I needed to have, 25 popcorn balls, how much butter would I need? So that's essentially the same thing. We need to use our imagination and our skills, our thinking skills, in order to get through that. So as you can see, we started out with 5 grams. So 5 grams is our starting point. It's what we have, it's what we want to have, all right? It's what we want to have. That is our starting point whenever we're actually creating that dimensional analysis problem. So 5 grams of carbon tetrachloride. And I recognize that I have grams. I'm looking for grams. It's not a direct relationship. The thing that I recognize and know is that this recipe is only in moles. All right, it's only telling us that it is in moles. So I have to make my conversion. I have to use a periodic table in order to make that conversion. So carbon tetrachloride. If I look on the periodic table, I would find that carbon is 12.0. I know you know how to do this. 12.0 grams, so 1 mole of carbon is 12.0 grams. Chlorine is 35.5 grams. And we have 4 of those. So when I add these all up, I come up with 154 grams. You can check my math of carbon tetrachloride. There's 154 grams of carbon tetrachloride to 1 mole of carbon tetrachloride. Now I'm going to take my recipe. I'm going to look at my recipe and say, how is this relationship related to my ingredient? So I have 1 mole, it's assumed 1 since we don't see a number there, of carbon tetrachloride to 1 mole of carbon disulfide. Alright, I don't see a number there either, it's assumed 1. So what I recognize is that I've just done some dimensional analysis. I can cancel my grams out, my moles out. I'm left with moles of carbon disulfide. And what I need grams of carbon disulfide. And I need to do the same calculation over here. Carbon is 12, sulfur is 32.1. There are 2 of those. When I calculate them out, that's 76.2. So I have 1 mole of CS2 is equal to 76.2 grams of CS2. My moles cancel. When I multiply my everything in my numerator and divide by everything in my denominator, my answer comes to 2.47 grams of CS2. Alright, so I've used my framework of what did I get from the refrigerator, okay, what should I have in my refrigerator, maybe is a better way to think of this particular problem. How is my recipe related, and what conversion do I need? Alright, so all of those elements in the kitchen sort of help us frame how to get through that stoichiometry problem. Well, if you found this to be helpful, please like it. Share it with your friends who might be struggling with chemistry as well. And remember, recognize that there are points of confusion in chemistry, but you can master your subject even through your points of confusion.